really encourage you to get on the HF bands, because that's where a huge amount of ham radio activity is and always has been. So totally worth getting there. We have lots of sunspots. The high bands are active. Little tiny antennas work pretty well. So that's what this talk kind of focuses on. All right, so you have a new HF station on the air, or maybe you have a new antenna up or whatever it is, and you really want to know, am I getting out? Or am I hearing well? Am I missing something? Or is someone missing me? So we'll talk about some tools. Most of the stuff is kind of internet related that can help you find out how well your station's working. So if beacons, reverse beacons, this DX cluster spotting network, a thing called PSK reporter for the digital modes, and another thing, the weak signal propagation reporter for if you want to do some precision measurements and comparisons. So one tip. Before I do all this other crap, you have to realize your ham radio for almost 100 years did just fine without the internet and all this other esoteric stuff. And how did you do that? You got on the air and you called CQ. And by golly, you'd see if somebody heard you. That was really a good way to go. Or you make a sked with a friend or something like that and you check things out. So if you don't transmit, you're just a shortwave listener. You go through all this effort to get your license that allows you to transmit. So get out there and transmit. So when all else fails, call CQ and see what happens. Turn the radio on, tune around, see what you hear. All right, so first we'll start off with beacons. So what's a beacon? Well, a beacon is anything that transmits continuously, hopefully on a known frequency that you can find. So you tune around until you hear it. You look in a list, find out where these frequencies are. You go find the beacon with the receiver, and it'll give you an idea whether or not the band is open. These beacons are located all over the world. So in the HF bands, the Northern California DX Foundation and the International Amateur Radio Union have founded a thing called the International Beacon Project. And there's a website devoted to that. By the way, I'm going to post these slides on the groups.io when this is done, so you get all the links. So they post all their information there. And there's also some beacons on 6 meters and other VHF, things like that. So guys who are trying to do some, if you will, DXing, that kind of thing on, especially on 6, but also on VHF. There are beacons there as well, but the NCDXF ones are really, really well designed. So they have 18 stations worldwide, and you can see the frequencies that they're on. It's 20 through 10 meters. And so they, on each frequency, they rotate through, and all these 18 stations sequentially, so they send their call sign, and then they send just a continuous tone in 4 different power steps. That's 110, 1 watt, and down to 1/10 of a watt. So you'll hear a call sign, of course, Morse code, and then you'll hear these continuous tones that are, decreasing loudness. Now, I don't know, this has a sound recorded. I have no idea if this will possibly play. Let's see if it will. So that was 4U1UN. It's in New York. And you could hear at the end the 4 different tones. So that's a typical beacon. They all sound exactly like that. He finishes, and a few seconds later, another station comes on, and so forth, round robin in a 3-minute cycle. So you can go to one of these frequencies anytime, just listen, and you'll hear various beacons. So if you can't copy CW, you can try a CW decoder or something like that and see what you hear. And you can see they're evenly spaced all over the globe. Oh, brother. Oh, that's nice. Okay, we'll try again. Hopefully. Okay, first, this has to go back into presentation mode, and then Alt-Tab, back, Control-Shift up arrow star to, yeah. The radio stuff I have no problems with. Okay, where is the Zoom sharing zone? There's a radio Zoom. No, not what I want.
Find it.
Have at it.
Go on. Right.
Right there, and then share, and then you got that. So just highlight the screen you want. Close enough.
There.
It's back. Okay. Hopefully we're safe now. Don't touch anything. It'll blow up. Now with any luck, I can go to the next slide. All right. And this needs to be in presentation mode. Okay. All right. The next thing is reverse beacons. So this is the opposite of going the other way. So the reverse beacons are things that listen to your signal. So the principle is this, is there's hundreds of receivers all over the world, maybe thousands. Is it okay online?
It's okay on Zoom.
Oh, it's okay on Zoom. It's not okay here.
Which is no.
Let's see, where is he?
It's a mystery.
Mm-hmm. I'm trying to mirror your
Oh,
screen.
it's a mirrored screen.
Extend. I don't want to extend.
Did you extend displays? You're on the extend display.
I'm gonna just duplicate.
That would be better.
How's that? Nope. Next. Okay.
There.
Use that. All right. Now double check
It-
on.
It should look good. Look okay. Okay. All right. So reverse beacons. So the idea is you have hundreds, maybe thousands of receivers all over the world that are listening to signals. These are computers listening for signals. And they run what's called skimmer software, which decodes particularly Morse code, CW, as well as radio teletype. And then all these detections are aggregated and reported to a central server somewhere on the internet. And then you use viewing software that lets you sort of filter the activity by like things like call sign or band or whatever modes, things like that. So what this allows you to do is find out if you transmit, you light up these skimmers all over the world and you look on a map or some listing and find out, oh, look, I'm being heard in these various places. So the main website, and I'll demonstrate this at the end, hopefully we'll be able to show the browser without any technical difficulties. This website, reversebeacon.net, is the place you go to look at all this stuff. And this information is also disseminated other ways. So first, what's a skimmer? So a skimmer is a wideband software-defined radio, one or more receivers hooked up to one or more antennas. So this is a receiver that essentially listens to the entire band or a very large portion of a band or several bands. And then the skimmer software is basically looking at the audio stream and trying to digitally decode the various signals that are there. It'll pick up certainly Morse code, radio teletype. There's no skimmers for SSB yet. For voice, not so much, but in principle, it could be done as well. So the software is very powerful. It can detect hundreds, thousands of signals in that bandwidth, decodes each one, and its main objective is to extract call signs. So what it's really looking for is the sequence CQ and a call sign or test and a call sign. So that basically that's what you have to send. If you call CQ with your call sign, be guaranteed many skimmers are going to pick you up. And then all that data is posted to the reverse beacon network. Once you send, a given skimmer will only report you once and wait like 10 minutes before it reports you again. If you want to get reported immediately, you have to change frequencies by a little bit, send again, and the skimmers will all sort of reinitialize and pick you up once more. So this is an easy way to find out, is this band dead? Is my antenna working? Is anything going on at all? You just get there, pick up frequency, call CQ or send test in your call sign, and bam, all these skimmers will pick you up and report it to the reverse beacon network. So,
question.
yeah.
On that reverse beacon network, is there some way to see how far you've gone? Because usually it just comes up with the nearest location that heard you.
So yeah, so the question is, how do you tell, where, who is hearing you, but where are they? Yes, there are some maps here. I'll show you. Shows a way to map the data all over the earth, so you can see exactly how far you've gone, distances and things like that. So these skimmer systems, especially multi-band things, some guys have put, I say a lot of work into this. There's K3LR on the left with an entire rack of equipment there, with a whole bunch of software-defined radios and PCs. And another guy, Jeff AC0C, he built these little software SDRs in a chassis and has, one very busy computer. So there's a lot of guys who've really invested in this to cover multiple bands. Here's the CW skimmer software, which you can buy. It's, I don't know, it's $75 or something like that. There's also one for radio teletype. And this is kind of what it looks like. Vertically is frequency and it's time going across. And you can kind of see, dits and dahs there. And then the list of call signs that it's decoded. That's kind of how the skimmer software looks if you're looking at the user interface. And normally this would just be on like some headless system. And it's looking at the entire band, decoding everything that it sees. So here's reversebeacon.net. This is one of the primary places you would go to look at these skimmer spots. As you can see, there's a map. So there's many different, choices and filters and things like that. For instance, you can filter, well, I only want to look at a specific band. I only want to look at a specific mode, something like that. And then I have an arrow there pointing, enter your call sign here. So what I did is I entered the call sign of my friend down in Orlando, Florida, and he was calling CQ on 15 meters one day. And you can see he has things lit up in Europe, Africa, Caribbean, all over the US, stuff like that. He's running 100 watts to a little spider beam by his house there. So that's a quick example. But all this information is there. It has, from left to right, it shows the spotter. That's the call sign of the station that spotted him. Of course, you might look up that station to find out, well, okay, where is W3UA, the spotter? This kind of helps you because it has done that for you and put a dot on the map where that location is. It tells you the distance between the two stations, the guy who's calling and the one who's listening. Gives you frequency, the mode. If he's sending CW, it tells you what speed he's sending. And there's a signal and noise measurement. Some kind of, it's not a super calibrated thing, but it gives you an idea. If you only got 3 dB signal noise, 20 dB signal noise, gives you a good idea just how strong your signal really is at that location. So that's quite a bit of information, and you can look back many hours. This website also has the ability to let you do sort of research. I mean, you can go back months even with this, looking for call signs and with all these different filters. And some guys will do that to find out, well, how are the band conditions, or comparing the performance of two different stations at a certain time in a certain band. There's tremendous amount of information available at this website.
Gary, on that, the dots that don't have arc paths to, what are they representing?
I have no idea. The dots with no paths going to them, I'm not sure. Some other spotters either didn't report data completely, no idea what that is. I want to say one other thing about reverse beacon. This data also, since it's reported to this website, and this website, it has an API, an application programmer interface, and other websites access this data programmatically. And one example is Ham Alert, because my buddy I was sitting next to was asking about Ham Alert. And Ham Alert's an app you can run on your phone. And Ham Alert, what it does is you can have it look for a country, a region of the world, a specific call sign, whatever it is. And what Ham Alert does, it goes out and primarily looks at these beacons and some other skimmer kind of things. And it can give you an alert on your phone that, hey, this call sign or this country on this band has been detected by one of these skimmers. So this data goes other places. It gets disseminated to other tracking capabilities. So you can imagine, here it is, I call CQ, type my call sign in here and look at the map, see where it lit up. Then I can look at the signal noise. Oh, look, my signal's really strong in this area. Very useful. The next thing I talk about is the DX cluster. So this is a thing basically for, its primary reasons for manually entered spots. That's where someone says, oh, I hear the station, I'm going to type in its call sign, note the frequency, I can add comments and things like that. And it gets posted, again, for public use on a centralized website. Once upon a time, it was called a packet reporter, because this data was originally distributed by good old amateur packet radio, if you remember that, like back in the 90s especially. Now it's on the internet. So sometimes they'll call did you hear that spotted on packet? And that's what they're referring to as this DX cluster. So anyone, anywhere can manually add a spot with optional comments. Optionally, the cluster will also include these reverse beacon spots, skimmer spots that we just talked about. And in order to look at the data, you can connect to what's called like an aggregator node, and I'll show you one of those, website, and obviously you can filter these things. So there's various websites that show this, and at the end of the talk, I'll demonstrate one of them, DX Summit in Finland. That's the one I usually use. DX Watch, eHam, all these different places have it. But also, if you use any kind of logging software associated with your radio, logging software always has this DX cluster built in. I'll show you one of those. And there's even some radios like Flex. They'll allow you to, on their waterfall display, it'll allow you to put this information. So you see a signal on your waterfall display, and it'll put the call sign right on top of it, tell you what that signal is. And that's all this cluster and reverse beacon information flowing in and finding its way to your radio. How cool is that? So you don't even have to listen to it. You already know who it is. So here's DX Summit, and this is one I use all the time. This one is especially useful for looking for particular calls, lets you look back in time. For instance, if there's a DXpedition on, you want to find out what band he's on or something like that, you can type his call sign in the search. And there's a box on the right where you can type in your call sign. I'm the spotter, the DX that I just heard, the frequency and things like that, and you put in comments as well. Sometimes the comments are pretty funny. There's not much space, but people manage to jam some really interesting and cute comments, and it's quite amusing to watch. It's like, it's a little bit like abbreviated Twitter for hams, something like that. So quite amusing, especially when there's a DXpedition on. They always say, worst DXpedition ever. That's very important to post that. Okay. So, and this is the cluster interface in a logger. This is the log for OM. This is what I'm using currently. And it has two different displays. On the left is kind of a data display, and it tells you, time, frequency, the call sign, everything is up there you could want to know. And in my logger, if I click on one of those, it will tune my radio there. Even if it's on a different band, bam, instantly I'm on that frequency, exactly where that was spotted, and my radio is ready to go for that station. On the right is a band map, and this is a very useful tool. You can pan and zoom the band map, and you can see all the call signs and which frequency they're on there and all the information associated with them. So, these are incredibly powerful, especially if you're, looking for DX or you're in a contest. The contesters use this all the time because you go down the band working stations as they're spotted. So that's the packet cluster. DXmaps.com is one way to display all this stuff in map format, as you can see there. This one, again, has tons of filters and stuff. You can filter by band and mode, parts of the world, all kinds of things. And it shows the call sign at each end and things like that. And you get a pretty good idea what's going on a given band. One thing is about this is this one basically displays only the sort of manual spots that people have typed in. It doesn't really display the things that are done by the skimmers and things like that. And these days, there's been a tremendous increase in activity on the digital modes, specifically like FT8, which you always hear about. And as a result, there's much less manual spotting activity of, say, CW or SSB. And this as a result, there isn't nearly as much sort of activity posted to a website like this or on the clusters in general. So, again, times are changing, but still, especially when it comes to SSB, there's no other way to spot SSB but manually at this point in the universe. So this would be the best way to see if there's SSB activity, and you can filter by that. So here's the big one these days is PSK Reporter. So originally PSK Reporter was invented when the main digital modes were, well, there was radio teletype, that's been around a long time, and then PSK, which is phase shift keying. PSK was sort of the first really popular modern computer to computer digital mode. And these days, once Joe Taylor came up with his special weak signal modes from WSJT, primarily this is devoted to like FT8 and some of the other modes, FT4, JT65, and all these other alphabet soup of digital modes. So PSK Reporter is probably the best resource overall. Now this again, PSK Reporter does have the ability to pick up some of the manual spots and some of the other reverse beacon kind of things, but really it spends most of its time and resources on essentially looking at FT8 reports, is what it amounts to. So anytime anyone anywhere calls CQ, let's say on FT8, anybody who has their receiver on running at WSJT, that CQ is reported to the central website. So there's thousands and thousands of people worldwide listening to thousands of other people worldwide who are transmitting. So as a result, this website is incredibly busy. It's hundreds and hundreds of spots per second are rolling into this thing from all over the world. I mean, it's just this big data problem. In fact, the website is overwhelmed most of the times. It's one guy and one computer sitting there trying to keep all this cooking. And sometimes, hey, this thing's not responding, seems kind of dead. And you go to his little forums, yeah, we got a problem. He's desperate for help on databases and things like that. So for those of you who have never done the digital modes like FT8 and stuff, this is kind of the data part of WSJTX. On the left is all the decoded signals. Every 15 seconds on FT8, there's another transmission interval. And so it records you, it gives you an idea of who's out there. You get a call sign, you get the location, that is their grid square, and like a signal noise estimate. On the right is where you're actually having conversation. The red highlighted ones were signals or communications that were sent to me, to my call sign. They're highlighted in red so I can see who I worked. So all these contacts go scrolling by, and anytime one's picked up calling CQ, like you can see them kind of highlighted in tan there, my station will report those to this PSK Reporter central repository. And so I'm just one of thousands of people doing that activity at this time. So the question here is PSK Reporter. This is what you see. Can you say too much data? That's the thing. And right now, this guy, he was looking at 1 million reports per hour rolling into this website. So yeah, there's plenty of data there. So up at the top is a bar that has all kinds of filtering options. Yeah, so you can see clearly this band, this 15 meter, was open, sort of worldwide at the moment I took the screenshot. And you can pan and zoom around, you zoom in on things and see who's where. So it has all these different filters across the band. So the first thing is have on what band show, well, you can also show country, show signals sent or received by anyone or by a specific call sign. So I could put my call in there. And then using what modes. By default, you go all modes, but you can filter to one specific mode if you're interested in that. And then over some period of time, 15 minutes is the minimum, it goes up to 24 hours. So if you want to see how well you're getting out, you get an FT8 and you call CQ and you wait a minute or two, something like that. And you go here and you type your call sign in. And then the screen will refresh, and keep calling CQ a few times. And you'll start seeing your call sign get identified on the map. So here's what it looked like. I called CQ for a while, and I set it up on 12 meters, show the signal sent and received by me for the past 30 minutes. And there's all these display options things. And in this case, what I did, I asked it, it shows me the elapsed time, how long ago I was detected, and it shows me the signal to noise at that particular station. So I can see, let's see, I was very strong down in Brazil. I was plus 21 dB. I can run SSB when it's like that. I was, I don't know, somewhere up in, it might have been Spain or something. I was minus 19 dB, is a lot weaker there. But anyway, you can kind of see how strong you are in what parts of the country or the world you're getting to. And again, if you put it back into report everybody, then you just get a kind of overall map of where all the activity in the world is. And this is just a phenomenal tool. You want to know if the band is open at all, this will tell you, assuming it hasn't crashed, from too much data. The last thing I want to talk about is Whisper, as it's called. So this is the weak signal propagation reporter. This is kind of a little esoteric tool. Ian, W6TCP, gave a talk on this a few years ago. And he actually has the equipment and stuff to do it. I'll kind of show you how it works. So what this does is, it makes use of the fact that if you transmit with a very, very narrow bandwidth, sending data very slowly, that'll give you the very best possible signal noise. You won't get much data through, but if you limit the bandwidth, you also limit the amount of noise that your receiver is picking up. So that's what this does. The bandwidth is like 7.5 hertz, very, very narrow bandwidth. And it takes 2 minutes to send a call sign and a grid locator. So it's very, very slow transmission. So this is purely a beacon kind of a thing. It has nothing to do with communications. It just sends your call sign and like CM97. That's all it would send. Totally automatic. It just runs and runs and runs, little unattended box. And then the results, as they're received in various places, lots of people, again, with receivers all over the world, as it's received, they get reported to a website. So the main reason for using this is really for like things like testing and comparing antennas or stations, or evaluating propagation from your region over long periods of time. You could run this thing forever, basically, and plot the data over a year. Say, wow, yeah, here's 80 meters. It gets better at night. It gets better in the winter and things like that. Or say you have 2 antennas. I got a vertical and a dipole. Well, which one is best? Well, I could set up 2 little Whisper transmitters. Maybe one has my call, portable 6 or something like that, running simultaneously, 2 different antennas sitting on my property. Then you go look at the reports and you'll see, you compare these 2 call signs, me and me portable, and you'll see, oh, this one is stronger in this area, but this one's stronger in that area, and so forth. So it's really, this is a purely technical or instrumentation kind of thing to test a station or test antennas. 2 ways this can be set up. One is you can just use whatever transceiver you may have and a PC running good old WSJT, which runs all the other digital modes. It also does Whisper. There's an audio connection. The audio goes back and forth. And then the CAT control to control your radio. This one also allows you to monitor. In fact, you can get on and monitor Whisper anytime you want. It just sits there and every 2 minutes, it'll give you a report of everything that it decoded, which can be things from all over the world. Oh, by the way, these are normally run very, very low power. 1 watt is considered very high power for Whisper. Most people run like 1/10 of a watt, something like that. It's very, very low power. That's the beauty of the very narrow bandwidth. The other way that people commonly do this is you buy a little device. Now, the original one was this thing called Whisper Lite from Soda Beams. You can see it, little palm of the hand, little programmed box. This other company called Zactec sells one, $139, very nice. And that little box got a USB connection on it. You program it up and say, I want my call sign on this band. Unplug, set it out there, hook it up to your antenna, and away it goes. It just sends your same little message over and over and over again until you turn it off. That's all there is to it. And then you would go to this website, wsprnet.org, and you have to create a little free account and stuff. And from this, like all these other things, it's a big data aggregator. Everybody who's has a Whisper receiver is reporting everything they hear to this website. So, I'm transmitting here, others are hearing me all over the place. I go and search for my call sign on this band, and this thing will give you again, like a signal report, and you get an idea, what distance, how far you've gotten on this. So again, this one really is an instrumentation or technical kind of thing for evaluating stations and equipment, rather than just something to find out if it's a good day. So summary, as you can see, there's all kinds of modern cool tools and stuff to see if you're getting out, see if propagation's any good right now, if the band is dead, or is it me? Somebody's dead, I'm not getting out. What's wrong here? PSK reporter is pretty much my favorite. A lot of times I'll bring it up on my phone. Like I want to find out, is 6 meters open? 6 is very spotty. And 6, the magic band, it comes and goes. You get a little opening to Europe, you better be there, because our openings to Europe are about, 3 hours a year from the West Coast. So if you miss it, you missed it. See you next year. So I'll have that kind of thing, and I'll look on my phone, PSK reporter. Oh yeah, look, 6 has something going on. And of course, it tells me how well I'm doing if I'm on a digital mode. The reverse beacons will tell me where I'm getting to on CW or radio teletype. For instance, just before a contest starts, or even during a contest, I'm constantly calling CQ, and I go glance at the reverse beacon screen and see if the map is lit up. If the map isn't lit up, it's probably time to change bands. That's a pretty good indicator I'm not getting out as well as I was before. And then I use DX Summit especially to search for special call signs. I said, if nothing else, turn on your rig and call CQ, because that's, really going to be the bottom line on finding out if you're getting anywhere. So I'm going to close this presentation if I can, so it will no longer be there. And the next objective is to try to share. Let's see how I do this time. There it is. This is, okay. Are we seeing a website? Yes, we're seeing a website. Good. Okay, I got that much right. I might stretch this out a little bit if I can. All right, a little quick demo of some of these websites. Right, this a little bit. There we go. All right, so here is dxsummit.fi. And as I say, this is one that you can use to either send spots or just monitor them. See a little flash of green there. That's something new that just came in and that it picked up. And it shows that, you can see here, G4KQY was reporting that M7W is on USB and he's on 6 meters. So this is just a big compilation of everything that's out there. Let's see, VP6D is on, yes? VP6 Delta?
No, Alpha.
Oh, VP6A. Okay, VP6A. There it is. So VP6A is a DXpedition. They're at Ducie Island. That's straight south of us, out in the Pacific. And I want to work this DXpedition. Well, what band are they on? Well, let's see. Right now, I scroll down the list and I can see they're on 10 meters, they're on 6 meters, they're on 20 meters. And then the column on the left is the spotters. So I look at the list of call signs in the far left. Who has spotted them? Well, they're being spotted all over the world. What I would look through, I'd look through the list and try to find someone who may be, say, on the West Coast who has spotted them, as an example. This also has the ability to go back in time. It has this a spot search. And also there's filters. I can say that I only want to listen to them on phone. Add that filter set, and I can see a number of places that they're on SSB. So that way I can filter, find out what bands, what modes, and so forth that a given station is on. So that's DX Summit. These are mostly manual spots. I got to look and see if any of the comments have, let's see, NorCal. See if anybody says, you know, worst de-expedition ever. There's normally problems with remote audio. QRX. Anyway, there's all kinds of different information there. You never know what somebody's going to post there. Sometimes it's simply hilarious. All right.
Gary, is there a filter for searching in the info box?
No. No filters for info. Let's look at reverse beacon. Okay, here's versebeacon.net. This nice map. And right now it's looking at everything. This is everything, everybody, everywhere. And you can kind of scroll around here and zoom in, see what's going on. Again, if you type in a call sign, I'll type in my favorite friend's call sign here. See if anything. Oh, yep, Dave's on. He's doing something there in Florida. And he was on 4 hours ago on 17 meters CW. And not working any Europe today there, Dave, unfortunately. So with this, again, that's all he had to do is call CQ and bam, he shows up on this map for the reverse beacons. And again, this data is available to any application that wants to tap into it. So that's all you have to do. It's call CQ, type in your call sign, and it shows up. Lee was testing out his radio teletype stuff. We're trying to get that going, make sure the signal, the modulation is correct. It's not upside down. There's not some other problem. Get on there and just keep hitting the button to call CQ a few times. Type his call sign into the reverse beacon, and it pops right up here. Let's see it. Let's see if Lee shows up here. You never know. Not recently, so not in the past like 24 hours or something. Next thing is the really hairy one. Here is PSK reporter. And this has lots of display options. Shows noise. That should work. And I will go to, let's see if 10 meters is open right now. In the past 15 minutes. So this is on 10 meters, everybody, all modes, go. And there's one display option. I'm used to having everything all set up at show connecting lines always. Yeah. Sent received by anyone. There we are. Okay, so here's what's going on 10 meters right now. You get some idea that right now it's mostly trans-equatorial from the US of A, not too much from the West Coast. Okay, so might not be red hot on 10 meters for us right now. Okay, I mean, and that's the kind of information you get. You can do this on your phone, and at a glance, you have some idea. And if you click on, any of these little dots, it tells you the call sign, sometimes even a comment about, what kind of antenna they have and things like that. So you see exactly what station it is and where they are. All the information is there. And then, you pick a different band. 15 meters probably is doing a little better right now. There we go. So right now we could probably, we could work a little Europe right now on 15, stuff like that. So there we have it. So that's PSK reporter. It's got tons and tons of data, and if you look at a particular station, find somebody who's doing something. N0AFU. Here's some guy, N0AFU. So here's this guy in like Colorado, and you can see those big flags all over the place. That's the places he's working into at the moment. Now that could be your call sign. You type in there and see what you're accessing at the moment, who's picking you up. Some of those people are just sort of running monitors. It doesn't necessarily mean it's someone you can work right now. They may not be transmitting. They just left the radio on. WSJT is just running. It's just monitoring, reporting crap, but they're not there at the station. So you say, oh man, there's this guy in this country I've always wanted to work. Yeah, it's just a radio with no human, unfortunately. So you don't know that unless you go and get on the band and actually like, listen for a while and find out who's there. All right. Okay, so that's PSK reporter. All right, I am done at this point, and I can probably answer some questions. I think we'll stop the share. And okay, so questions on getting out. Nate?
What are some of the modes, and maybe this is perception and my green is showing, it feels like some of the modes tend to overlap on top of each other. And I'll pick on FT4 and FT8 because they're both JT based protocols. But a lot of times people report to me when I'm on FT8 or when I'm attempting to ruin CW that I'm bleeding into one side or the other. What are some of the ways you can use to check and make sure that not only are you getting out, but are you getting out how you think you're getting out?
So you're talking about more about like a signal quality issue, something like that?
Roughly, yeah.
Yeah, that's an interesting point. There's a couple of funny things that happen. One is with the reverse beacon network, specifically on CW. Sometimes you find you send CQ and you find yourself reported on like two different bands at the same time. You're transmitting on 7 megahertz, you get spotted there, and you're being heard at 14 megahertz or 21 megahertz, like a harmonic, something like that. Like, well, that's interesting. How come I'm on 2 or 3 bands at once? Well, that could be your own transmitter is being horribly overdriven, something terrible is wrong with your amplifier or whatever. It can also be the fact that the skimmer receiver is being overdriven and it's seeing you on several bands. And that usually means what you look at is you see in reverse beacon, one of the things it gives you is a signal to noise ratio. And you look at the signal to noise ratio and it's some huge number, it's 40 dB or something like that. Like, I'm clobbering this guy, overloading his receiver. And he's the only one who's reporting me on more than one band. Technically, the same kind of thing in theory could happen on the digital modes if the harmonic happens. I don't know if this ever happens. I don't think it does. There's no harmonics that line up. You'd have to be on one band and have a harmonic on another band that happens to be in the little narrow window that everybody listens to for the digital modes. And I don't think there's any of those that work out that way. So, and other than that, everybody should have somebody else who they believe to be competent listen to your signal on all modes. You should always test your station. Do it more often than not. That especially, I mean, CW isn't too bad, but SSB, it's very easy to overdrive an amplifier or something like that, have just horrible audio. The digital modes, you drive the radio too hard, the ALC is going up, and you can just splatter all over the band, you make a big mess. So it's very, very good to have someone else evaluate your signal. Iran?
One way to test it, if you don't have somebody to test other than yourself, is to go to one of the remote SDR stations and transmit to yourself. So choose one that you can get to, and you can usually do that by looking at the spectral display and put on earphones and call a CQ to yourself and see how you sound.
Exactly. Yeah, the remote SDRs are all over the place. There's a really good one it's over at Point Reyes, and that's a really good receiver. It's very sensitive, very low noise and stuff like that. And it's a website you just go to and find all these remote SDRs. Yeah, and by golly, you can hear. So we had a signal problem from my station. It was caused by the audio going over remote over the internet, and it was chopping things up. That was screwing up the signal. But you can't tell, yourself. You have to have another receiver. So that way, the robot was able to listen for me. Clancy?
Yes, Gary. How do you find the frequency of these remote SDR sites?
It's their web SDRs.
Yeah.
I'm going to take a quick look at the old, I have a browser in front of me. Why not try web SDR? WebSDR.org.
Okay,
WebSDR.org is probably the place to go. And yep, that's the place. And you go scrolling through the list, and you find one that you like, click on it, and it'll hook you up to that web SDR, and you can tune it and listen to it in different modes. So that's another good way to test your audio. That's where, like for SSB, you use recorded audio on your transmitter. So you just hit the send button while you're listening to the web SDR. That's a good thing to do.
Did you mean point raise that you said a while ago?
Yeah.
Because I only are familiar with that one that's right at the bottom of your screen, that KFS. Yeah, that's the only one. Is there another one in there somewhere?
Yeah, KFS. That's the one.
I see.
Yeah,
The other
KFS.
good one is the Utah one. I've heard Utah a lot.
Oh, okay. Northern Utah one. Yeah. KF. Yeah, I mean, KFS is the one I've always used.
I only
I think
thought
it's the
KFS
northern
was San
Yeah.
Francisco. or Pacifica.
Yeah, KFS kind of shows what it's doing there. So it's amazing. You know, you're remotely tuning, some little robot radio by remote control and listening to it. It's very cool.
And the other
Yep.
thing you can do is record, so you don't have to have headphones and all that, or record your voice.
Yeah, so the suggestion is if you have the web SDR, you can record the audio, from your PC, and review that later. And it's kind of hard to talk while listening to your own self, delayed by a few seconds. That's real trippy. Not too bad if you're listening to CW or something like that. Just send and hear what you hear. Yep.
you were saying earlier, along with CQ, you can send test.
Yeah, to trigger reverse beacons, it wants CQ call sign or test call sign. Either one is fine. And the same is true on CW as well as RTTY, radio teletype. Yep. There's Ron again.
Yeah, I'm just trying to make Jerry work. I watched to see when he went to the far side of the room.
Yeah.
And then I call them back.
That's right.
So what if you are still into kit building, you can get one of the Whisper transmitter beacon circuit boards and all the components. I think they were about $80. And it has a little processor and all the filters and stuff. Use a little sine wave. It uses a square wave generator that's heavily filtered in order to get a sine wave. And it's about 1.25 inches wide and about 3 inches long. And there's three boards. And again, about $80. I have to put mine back on the air again. I bought it during the sunspot minimum, which is not a good time to buy a little 100 milliwatt device. So, but they're fun to put together. You get back to soldering again. And that one you have to program with 2 buttons rather than using USB. The one I had anyway, they probably updated that. You had 2 buttons. So you had command select, and then you could do kind of like a letter of the alphabet at a time to enter everything. But it was kind of fun to do. So it's another kit if you're still in the kit building.
Yeah, the whole Whisper, it's all open source, and people have designs for Arduinos and for Raspberry Pis and things like that. It's fun to experiment with. And don't underestimate what Whisper can do. There's guys on 160 meters running 100 milliwatts, heard all over the world. It's just absolutely incredible. It doesn't seem possible, but the secret is narrow bandwidth, very slow transmission. Yep. Amazing. Okay, that's it.
Thank you.
All right.